Pretend the whole ball is a solid one thing, just like an atom. That's the analogy we're making. A separate ball is analogous to a separate atom. There are no bonding issues to worry about.
So we've established that there's no intermolecular bonds in a gas. Thank you very much. So to be comparable, solids have no intermolecular bonds also?
There are no intermolecular bonds in a gas.
And what about a solid? Has a solid got intermolecular bonds to make it comparable to a gas?
There are no intermolecular bonds in a gas.
Your equivocation between inter and intramolecular bonding at an atomic level. Now, gases don't have any intermolecular bonds, and solids do. So therefore, solid bonded bouncy balls are not analogous to gases.
Because they're separate. The separate atoms in a gas are not bonded to one another.
Bouncy balls are bonded though, aren't they? That's our point. Maybe ignore it.
I missed you over talking.
I know you're stuttering now, bit.
Okay, there would still be the odd ball that would bounce up due to random collisions causing one ball to acquire more velocity than would be required to go out of the container. That's not the same as it filling the space. That's just the odd one creeping out and then having to return when get a little bit higher than the top of the container, and then it would fall back in due to gravity because there's a force acting on them, Nathan, just like there's a force bonding a brick together, and that's why that's not subject. Well, you could ask yourself, why doesn't a brick be subject to entropy and then disappear off into space?
Okay, I'll ask. Can I ask? So does a brick have intermolecular bonds holding it together?
It does. And
does a gas have intermolecular bonds holding it together?
There are no intermolecular bonds in a gas. And what do you think those intermolecular...
Maybe ask me a question. So a brick, and when I ask you why it's not flying apart, it's because of intermolecular bonding?
Yes. Well, it implies a force to the gas molecules, just like the intermolecular bonds in a brick hold the brick together.
And there's the same intermolecular bonding force in gas, right?
No, there's not.
Oh, right. So they're not analogous then. So when we point out that PhD clown show Thunderfoot says that gas behaves like bonded bouncy balls with intermolecular bonds, a force holding them together, behaves the same as unbonded gases that expand in all directions to fill the space with elastic collisions.
Bouncy ball is subject to friction. It's not perfectly elastic.
You're saying these two aren't the same. They're not analogous, right? Yeah, we know.
That? Well, it's what my textbook showed me when I was getting my PhD. I said, yeah, but is that reality? How does that work? Isn't that a violation of a natural law when you say that? If they don't wake up, that you could be...
Why did you just claim that we say that the vacuum of space is next to a high pressure? It's exactly what we don't say. It's very, very close to very, very low pressure. And that very, very low pressure is close to other very, very low pressure. And you have to go down 60-odd miles before the pressure starts to get to reasonable values, and then you have to go down a bit more to get to the pressure we experience on the surface of the Earth. You don't even understand what the globe model claims, let alone attempt to refute it. So he was pointing out to the Earth, and he pointed out to a picture of the Earth where he said, here's space, and here's next to the gas pressure, full gas pressure of the atmosphere.
Well, if you would allow other people to speak, maybe they can comment on the question that you should wait to ask until they're done.
What pictures are you talking about? I'm just asking for information about what your point is.
How would you know if you keep interrupting and I can't finish?
Okay,
so, for instance, what you're saying is you've seen pictures of the Earth in space, and you're claiming you've seen pictures, presumably, of the atmosphere next to space. Is that what you're trying to say?
Well, I've got a picture on screen now. Is that a good enough one as an example?
I can't see it. I have to go and start up YouTube.
No worries. While you start up YouTube and have a look at what's on screen, maybe you can clarify verbally. Is the sun claimed to be in 10 to the minus 17 Torr vacuum?
Space is very low. I mean, it varies, but yes, it's almost a vacuum. Yes,
so
space
is the sun claimed in your model to be in 10 to the minus 17 Torr vacuum?
Well, the pressure next to the sun is slightly greater than that because it emits material. So it's not quite sitting it, but yes, the space around it is effectively a vacuum, yes.
Okay, so we've got Rumpus making clear that the sun is claimed to be in 10 to the minus 17 torr vacuum. Here's a picture of the sun, and here's a picture of high pressure gas. And it's claimed by Rumpus that this area is a vacuum, 10 to the minus 17 torr, as per the rhetoric of heliocentrism. So we have high pressure gas and a 10 to the minus 17 torr vacuum, and gas not filling it. Now he's going to say, well, it gradiates to this. All right, well, this is still claimed to be 10 to the minus 17 torr, and this is definitely high pressure gas, and according to you, this is a vacuum, and this gas isn't filling it. That violates the second law of thermodynamics. If the sky was a vacuum, then the gas we breathe would fill the space.
Forces, Nathan, that pulls you down to the ground. What do you think that's called? What do you think that does? And it does the same thing to air molecules as well.
Oh, does gas go down, go boom boom, like bouncy balls poured into a fish tank, as asserted by Thunderf00t?
What do bouncy balls do when they hit the ground, Nathan?
Is gas like solid, bonded, bouncy balls, as asserted by a PhD clown called Thunderf00t, who asserted, with demonstrations, that gas is like solid, bonded, bouncy balls when poured into a fish tank? My question is gas like solid, bonded, bouncy balls?
Bouncy balls do when they hit the ground.
Is gas like bouncy balls?
Exactly, yes.
No, gas is unbonded. You are stupid, and as a flat earther, I feel it's only right I educate you. Bonded bouncy balls are solids, a completely different state, not the same phase as gas. Gas is unbonded and expands in all directions. Have you never boiled a kettle? The gas is not going down like a solid bonded bouncy ball, because that's a solid and behaves like a solid. Gases are unbonded, Rumpus, you are stupid.
Bouncy ball...
aren't solid, right? You're telling me that they're not solid, they're like gas.
The atoms in a gas and molecules in a gas, it can have atoms and molecules,
are they
solid,
bonded?
just like bouncy balls.
Are they bonded? Are they bonded?
They are solid things. The fact that the ball is made up of little bits of things is irrelevant. We're talking about the behaviour of the ball as a macroscopic thing. We can't see atoms. So to provide you with an analogy you'll understand, we'll say, pretend the whole ball is a solid one thing, just like an atom. That's the analogy we're making. And it behaves. And remember, we're talking about the behaviour. It's the behaviour we're describing we're interested in. We don't care about the contents of an atom. We don't care about it's made up of gluons and protons. And we don't care the ball is made up of atoms. We're talking about the behaviour of the two things.
Two things? What are the two different things that we're talking about? Two things, you say? What are the two things?
I missed that because you overtalked me.
You said two things. So we're talking about solids and gases. Two things, right?
The atoms inside a gas are just as solid as the atoms in a solid.
Oh, I see. You're convoluting between inter and intra-molecular bonds then.
Convoluting means, do you?
Hey, you're talking through me when I point out what you're convoluting. You're trying to convolute between intra and intermolecular bonds, right?
I'll say it again, a bouncy ball...
You ignored me! So you're equivocating, and you're just going to ignore me clarifying that by talking through me and ignoring me, right? What a coward! So what Rumpus is doing is he now continually talks through me, because he's not going to listen from this point, he's been pummeled, is he's trying to convolute between inter and intra-molecular bonding. Now, at a fundamental level, intermolecular bonds aren't going to be equivocated between gases and solids. But obviously Rumpus isn't going to listen to a word I'm saying. He's just talked non-stop through every word I've just said, because he's an abject coward and knows that this is the point his argument dies. So he has to constantly talk from this point forward, so he doesn't have to listen to me and therefore address anything I've just said. He won't repeat my pointing out that he's equivocating with inter and intra-molecular bonding. He's not going to acknowledge that ever.
A separate ball is analogous to a separate atom. There are no bonding issues to worry about.
Is that an inter or intra-molecular bond that you're describing?
We don't need to worry about any of
We don't need to worry about it. It's just my debunking of your point that you're using, so we don't need to worry about it or answer it, right? You utter coward. You're getting pummeled by a flat earther again.
the molecular bonds in a gas.
Are they
Otherwise it would be
intra?
a solid.
Are they intra or intermolecular bonds between gases?
Well, an intra is inside the molecule. If you have a single atom, there's nothing for it to be bonded to, so you don't know what you're talking about.
So is a gas feeling the effects of intermolecular bonding or not?
Atoms and molecules in a...
Not listening to me. Clarifying my question, he's just talking through the end of it, ladies and gentlemen, because he knows he's getting pummeled. What a coward. So I'm trying to clarify whether or not gases have got intermolecular bonds or not. And he's just talking through me, so he doesn't have to answer. What a complete bitch.
Bonds in a gas, you twat. There are no intermolecular bonds in a gas. That's what makes...
And are there intermolecular bonds in a solid?
You're a liquid.
He's not listening. So we've established that there's no intermolecular bonds in a gas. Thank you very much. So to be comparable, solids have no intermolecular bonds also?
There are no intermolecular bonds in a gas.
And what about a solid? Has a solid got intermolecular bonds to make it comparable to a gas?
There are no intermolecular bonds in a gas.
Yeah, I know. That's what our argument is, yeah? It's not bonded like a bouncy ball that does have intermolecular bonds. But you just seem to be ignoring me because you're a coward getting completely pummeled by a flat earther. And as pointed out, your equivocation between inter and intramolecular bonding at an atomic level. Now, gases don't have any intermolecular bonds, and solids do. So therefore, solid bonded bouncy balls are not analogous to gases.
Because they're separate. The separate atoms in a gas are not bonded to one another, and that...
Like bouncy balls are. Bouncy balls are bonded, though, aren't they? That's our point. Maybe ignore it.
I missed you over talk.
I know you're stuttering now, bitch. That's right. Bonded bouncy balls, though, right? Solids are bonded, though, aren't they?
They're not bonded.
Solids? Solids aren't bonded? What holds them together, then? You're telling me solids aren't bonded? Wow, another demonstration of Rumpus's abject stupidity. He thinks that solids aren't bonded? What kind of a moron are you? Is it just that you can't listen? You're choosing to talk through me pointing out that solids do have bonds. Like bouncy balls are bonded together, unlike gas.
Saying the behaviour of the whole ball is analogous to the behaviour of a whole atom. The fact that a ball...
Oh, an atom? What, something you're describing with an intramolecular bonding? Well, solids don't have the exact analogous comparison when you say that one atom of gas does have intramolecular bonds but doesn't have intermolecular bonds, as does a solid, making them incomparable, different states. Gases are unbonded, as admitted by Rumpus, making them a false equivalence when using bonded bouncy balls. PhD Thunderfoot Clown is a moron and doesn't understand this, and has therefore drawn a false comparison. Bonded bouncy balls aren't like unbonded gases. Now, obviously, there's been a lot of fun demuting, ladies and gentlemen, while I'm pointing this out to you. That's why Rumpus's light is continually flashing, so he doesn't have to acknowledge the point that he's been pummeled on. That would be to say that gases are unbonded, and bouncy balls, solids, are bonded. No way he's ever going to accept that, acknowledge it, or in any way defeat it in an argument. But he can talk through it's a Discord, can't he?
Does a ball dropped onto the ground...
Does it have an intermolecular bond, a ball? Because we've established that gases don't. So does the ball have intermolecular bonds?
It don't stay on the ground. That's what atoms...
You're just talking amongst yourself whilst ignoring every word I say, you abject coward. Now the audience knows what's going on. You're getting pummeled. I'm explaining to the audience that you've been annihilated while you ignore me. We're trying to establish if bouncy balls have got intermolecular bonds and you're ignoring me.
Doesn't matter.
Doesn't matter, it's just making it comparable because they both don't have intermolecular bonds, solids and gases. They're both the same, really, it doesn't matter, other than it being the point that I annihilate you on, and you hand wave by saying it doesn't matter. Why doesn't it matter that bonded bouncy balls have got intermolecular bonds and gases don't have the same exact intermolecular bonds, in fact are unbonded? Precisely my point. Not mattering? Oh, it does matter. It's crucial to my argument that you're talking through, because you know that you've been defeated. So therefore, a constant barrage of talking through me and not listening to a single word I say is all you've got to defeat this rumpus. You already know, so I don't mind shutting down your line while you do that, so the audience can hear how you've been pummeled. You're equivocating between inter and intramolecular bonds as described immediately when I caught you on this. You just didn't think I was smart enough to realise what you were doing, and now all you can do is fundy mute me the entire time. What a coward. Your time here is done. You've been pummeled. Any last words?
The behaviour of the whole ball is analogous to the behaviour of a whole atom.
Is it inter...
Oh, no, it isn't, Rumpus. Can I have a minute on that?
Yes, it is.
This is the whole...
The behaviour of a
reason.
whole ball is...
Please, can you stop repeating it, Rumpus? Adam would like to respond to you, you coward.
Okay.
Maybe we should address that. The point here is the demonstration is supposed to show the bouncy balls acting like a gas molecule, right? Now, the interesting thing about gas behavior is they're free to move in all directions and undergo elastic collisions. When you drop those bouncy balls, Rumpus, do they undergo elastic or inelastic collisions?
A very bouncy ball does do something very close to elastic conditions, and that's why the analogy
So
is not
inelastic then, yeah?
enough. It's good enough.
Yeah, so inelastic, Nathan.
Very
it's
close
not good
to
enough, and
elastic.
this is why. So I'll get on to the next point. Because it's inelastic, and because the bouncy ball behavior isn't analogous to gas behavior, if it was, when Thunderfoot Clown dropped the bouncy balls into the container, what would have happened if it was analogous is the bouncy balls would bounce around until entropy took over and the vector paths of the bouncy balls would all leave the container. But they don't do that. They all just plump to the bottom within seconds. Now, if it was analogous to gas, after a short amount of time, you would see less and less bouncy balls in the container. They would all fly off because it's not sealed at the top. Okay?
Yeah. In other words, if the sky was a vacuum, the gas we breathe would fill the space. It's the second law of thermodynamics. It's very easy to look up. It's very easy to describe. But if you equivocate gas that's unbonded at an intermolecular level with bouncy balls that are bonded at an intermolecular level, you can make gas go down, go boom, boom, when a kettle debunks that.
To talk to you in everyday objects because you're a moron. We have to talk to you.
No, it's just straight into the ad homs, Rumpus. I'm going to have to remove you because you didn't listen to a word Adam said. You spoke through it the whole time. I put my mouse next to you for the audience just to show that you weren't listening. You know and have known for quite a period since you've been here that you've been defeated in this argument. So you're not listening anymore. So you're not really much use to anybody if you're not going to listen to anything anyone replies with and just try and censor it from people's hearing. That's pretty pathetic. But there we go.
Hey, everybody.
Hey, Brian. How's it going?
Brian?
Science denier. You don't understand science.
So you're just going to ad homus the whole time, Rumpus, and not listen to a word?
I have a question for Rumpus.
And we haven't even
If
gotten
he's
to the
willing
Black
answer.
Swan yet.
If you truly,
But
he
bouncy
said
ball,
yeah.
then would you accept that as being
He's
a
not
correct model
listening.
for the
He's
atom?
just talking constantly.
are
Right?
you,
He's not
are
listening.
you still there, Rumpus?
I've not been
Not
given-
listening.
You've been overtalking me constantly. You've not
Rumpus.
given me a chance to answer.
See, he's just talked constantly for the last 5 minutes straight and is now saying he's not getting a chance to answer. He's not listening. He's not listening to anything anybody says
He's not
to the point of
listening, no.
defeat.
Well, Rumpus, if you're willing to answer my question, that will put it all to bed.
More
Are
than
you
happy
there?
to take turns with people. More than happy to take turns, but I don't get a chance to finish my answers.
Okay,
So the
60
bouncy
seconds for
ball
Brian.
analogy
You didn't
is
let me-
fine.
Okay, Brian.
Not
Shush.
perfectly
Discord.
elastic.
G plus. Hello. Okay, go ahead, Brian. 60 seconds.
Okay, Rumpus claimed that the atmosphere, which is begging the question fallacy, but just by that word alone, gradiates from ground level pressure right up to become a vacuum, eventually becoming a vacuum of space, 10 to the minus 17 torr. So that's a 760 torr at ground level becoming 10 to the minus 17 torr gradually. So now I would like Rumpus to provide me and everyone else on the panel with a physical demonstration of a gas pressure gradient being created within a vacuum chamber without solid containment between the gases and the vacuum. As that would prove
The thing is,
his point.
Right, but the trouble
Feeling-
is, you need gravity, because gravity is a very special force. It acts on each thing's individually, like
That
little
is the end of
springs
that.
acting on all the molecules. And if you understood about potential energy and kinetic energy, you do require the gas molecules running around the atmosphere, running about 500 meters per second. And
I
they will, if you were
asked
to
you
throw,
not
if
for
you,
an explanation. I asked you, can you
I'm trying to give
provide
you
a
an answer. You're
demonstration,
interrupting
not
me.
explanation.
Brian, I'm trying to answer here.
He asked for a demonstration, though. He didn't ask for an answer. He asked for a demonstration.
Brian, if I were to throw a ball up at 500 meters per second directly upwards, how far do you think it would go? I'll tell you what, I'll answer the question for you.
Why? Why are you
care.
answering your own question? What a scumbag. So the first thing we need to establish, Rumpus, while you
Because
talk
I'm
through everybody, I
explaining-
thought you just asked a question. You're not willing to get an answer? So the first thing I'd like to establish with you, Rumpus, is does this ball, like a gas, have intermolecular bonds?
Doesn't matter.
Oh, right. It's only the definition of the destruction of your argument.
Not irrelevant. We're talking.
Not relevant, other than gas is unbonded and the bouncy ball in your analogy is bonded. It's just the defeat of your argument. It's not that it's not relevant. It's where you get pummeled. But you don't have to like it. I don't mind. That's okay. The audience knows you're an abject coward, and hand-waving it by saying it doesn't matter when I've tried to point it out and you've talked through it every time just shows how badly you've lost here, Rumpus.
It just goes to show you have no argument. That's why you have to.
No argument? You've just told me my argument doesn't matter. I ask if, like gas, this ball in your analogy has intermolecular bonds or not, and your answer is, it doesn't matter. Well, can you tell us if it does or doesn't, rather than telling us it doesn't matter? Do you not know? Are you stupid? Don't you know the answer? Because saying it doesn't matter isn't saying you do or don't know or giving the right answer. It's showing your stupidity, Rumpus. And throwing your dummy out of the pram, talking constantly, that doesn't change the fact that I don't know isn't crossing your lips. It doesn't matter. Just shows you're stupid.
Claims to be a debate channel, and he's not interested.
Well, I've asked a question. You've said it doesn't matter. You haven't said I don't know. You haven't given the right answer. You've said it doesn't matter. That makes you stupid.
He's frightened the debate. You see, he will not.
Yeah, the debate has reached a point where I ask you if the ball in your example has intermolecular bonds like gas doesn't, and you say it doesn't matter. That's not I don't know.
5 words I got out there before I was interrupted. Must be 4, possibly 5 words. And I'll say it again.
Well, you can suck my balls. I've got my answer, and your answer is it doesn't matter.
Sentence. I can't finish a sentence, can I?
Now it's just constant fundy tactics with I can't finish a sentence. Your answer to my question, does the ball have intermolecular bonds like a gas doesn't have? And you say doesn't matter. That's not an answer.
You can't cope with the debate at all here. 5
This
words.
is a debate. You just don't have an answer to my question. You said it doesn't matter. That's not an answer. That doesn't show you know or understand or don't understand. It's a hand-wave dismissal.
What his idea of debate is. One where he mutes other people. That's his idea of a debate. So,
Sorry, your tactics aren't going over, scumbag Fundy. I've asked you if a ball in your example has intermolecular bonds, and your reply is it doesn't matter.
you can all see this. You can all see this. Can you see this? I cannot finish a sentence. Right, so we're talking about the behaviour being analogous. It doesn't matter the constituents of a ball. We're talking about the behaviour of a ball.
Do the constituents affect the behaviour of a ball? Adam Meakin, can you answer this for me, please?
Well, yes. I think the last
What's the
time
question?
I was
What's the
talking,
question?
Rumpus, you talked through me, so maybe I could explain it again for you.
No, you talk
trying
through me.
to-
You wouldn't let
Oh, Rumpus won't give you more than 5 words. He's a coward Fundy being absolutely annihilated, so he won't give you more than 5 words. Do you see what's happening, ladies and gentlemen? Rumpus won't allow his opponent to talk.
He didn't let me finish.
You're denying that this fundamental property of gases and solids has an effect on their behaviour. You've said it doesn't, and we've got somebody who's an expert to answer, and you won't let him because you're being
Go on,
pummeled.
then. You interrupted me, but nonetheless.
No, you interrupted Adam. Cowardly interrupted the expert. Yeah,
he's
Adam.
not an expert.
Yeah,
is he?
Rumpus. Right. So you're trying to say that the behavior of the ball is analogous to the behavior of a gas molecule. And I
Yeah.
think this is the point that it's fundamentally not. Is a gas molecule's collision elastic or inelastic?
Right, and here we go. And you interrupted my answer, so you never heard my answer to that. We can think, if
But
you want, in a model that it's perfectly elastic.
Oh, sorry, I don't want to think about anything in a model. We're talking about in reality, you dumbo. Don't immediately reify models and mathematics. He's asked you a physical question about physical reality, you Dumbo.
And Nathan couldn't hold it in. He didn't like me exposing him as an idiot.
No, I exposed that you are now going to a reification of a model.
I can't give my answer, can I? I can't give my answer.
No, you don't want a model-based answer. Adam's asking about reality. Dropping a ball isn't what a ball drops in a model.
I'm interested in an answer.
Yeah, we heard that you're going to talk about a model, and we're not interested. Is your question based in abstract maths and models or reality, Adam?
Not being allowed to give an answer.
I'm asking for clarity about whether or not the answer required is abstract or physical, Grumpus, but you're not letting that clarity come because you know that you need to use an abstract model.
He can only interrupt. He's not interested.
Yeah, he's choosing to use fundy tactics. I'm trying to gain clarity from Adam about his question. Rumpus won't allow it. He knows he's getting beaten.
But you can all see this, people. This is from the scared Nathan Oakley.
Yeah, another ad hom. Trying to gain clarity from Adam about whether or not we need an answer in the abstract or in the physical, but you're not allowing it.
You cannot expose an idiot in debate. So a bouncy ball is close.
No, you're not allowing Adam to give clarity. You're just going to keep rambling on with your own rhetoric. Adam, is your question in regards to fundamentalist abstract models or about reality?
Well, no, talk about the reality of gas behaviour.
Reality, not model-based abstractions then.
No,
so go on, Adam.
We're
Try
talking
and
about
think
reality,
of a perfectly
aren't we,
elastic bouncy ball, and then it's very analogous. Think of a slightly improved bouncy ball, and then you're there.
Yeah, but that's not what the model had, did it? So this is my point, Rumpus.
No,
So
the model had
he's not allowing it, ladies and gentlemen. Abject coward. Abject coward. Adam was talking. Can't allow it. Abject coward.
The model has perfectly elastic balls. The model does. The model is perfectly elastic.
Oh, we've just explained we're not interested in your abstract model. Shut up. Go ahead, Adam.
Represents reality.
Oh, you're not going to let Adam. You're obviously scared of the expert. Yeah, I get it. Coward.
Can't see the Nathan, so
you're not letting the expert speak. You're just talking through him. Coward. Go ahead, Adam. Fifth time.
In your abstract model, Rumpus, would the bouncy balls stay in the opened container? I.e., would their behaviour be analogous to the real bouncy balls in real life, or would it not?
Force called gravity that acts on you and acts on the balls.
I just rambled through that,
exactly, and the balls would not leave an empty container if they've got the force of gravity acting on them, just like you can't jump up into the air.
Your abstract model wouldn't match Thunderfoot's clown's demonstration.
I was only 5 seconds of finishing there, and you felt you had to interrupt. So just like
you can't jump the point.
Up and leave...
Your abstract maths, would it match Thunderfoot's clown's demonstration?
Atoms or molecules of a gas leave the atmosphere, leave the Earth, is it because there's a force of gravity pulling them down?
In your abstract model, would the bouncy balls remain at the bottom of the container in your abstract model of elastic collision?
Because they bounce, just like bouncy balls bounce, they bounce up again.
Did Thunderfoot clowns, bouncy balls, bounce up again and leave the container eventually because of entropy?
I can't remember what his demonstration did, but obviously,
do you think his bouncy balls...
Oh, I'll remind you. No worries, Adam. I'll just remind him. What he did was he poured bouncy balls into a fish tank, and they went down. Go boom, boom, because they were solid, bonded.
Yeah, but that's
bouncy balls.
That's because they're not perfectly elastic in those situations.
So, was his example then analogous to gas behaviour, Rumpus?
It's close enough. It's a good enough start.
That'd be a no then, wouldn't it?
That'd be a no then. So close enough. It's not analogous because gas has elastic collisions. Does gas not have elastic collisions? Do you not understand gas behaviour?
The bouncy ball is subject to friction. It's not perfectly elastic, so it's not.
It's not. Is gas perfectly elastic in its collision state?
Close enough. It's close enough for people like you to understand.
Oh, it's close enough for us flat earthers. No, but we understand that gas has elastic collisions and the bouncy balls don't.
Another question, Rumpus. Do bouncy balls, are bouncy balls subject to density disequilibrium and are gas molecules?
Oh, he won't allow the question. He's not allowing it, Adam. He's not allowing it.
Well, you answer my question first, Nathan, then I'll...
No, you can suck on my nuts. That's what you can do. Adam was trying to ask you a question. Maybe quickly assert the authority, take control, ask a question. Adam was asking you something, you just interrupted it. Can you not tolerate? Are you scared of Adam's question? Go ahead, Adam. Oh, great. Go ahead, Adam.
Okay, so gas molecules aren't subject to any
Adam?
density disequilibrium effects. They are the medium, aren't they? Whereas this bouncy ball is a denser object acting in the medium of air, isn't it? So is that subject
those
to
bouncy
density
balls out. So
disequilibrium,
hold
the
on, you
bouncy
could
ball?
put
Oh, the question
is
wasn't
the
being
individual gas
tolerated.
molecule
The
subject to
prerequisite got allowed, but
density?
the question wasn't. He immediately interrupted, and he knew you were going to be taking control of the situation by asking him a question, so he had to interrupt it like a
you could
coward.
put the bouncy balls in a vacuum.
Yeah, no, we're not hearing your question. We were hoping for Adam's question that you had to interrupt so the question didn't come, because then you might have to answer it, right, Rumpus?
The bouncy balls in a vacuum.
No, we're not listening to your constant fundy muting anymore. We're pointing out that you interrupted the actual question.
Answering his question.
No, he didn't get to ask it. You
Rumpus,
interrupted it.
You're not changing the question either. You're asking me if I make the density disequilibrium even more severe, will it change the
Put the
results? No, it
bouncy
won't,
balls in a
Rumpus. So
vacuum,
carry
you
on.
wouldn't
Oh, he did it again. As soon as the question
Yeah.
came, he started talking through it because he knew that he might have to answer. Maybe you can answer for him like he thought he was going to get away with doing.
Still trying to answer his question. You could put the bouncy balls in a vacuum, and then you wouldn't have the problem you're describing.
As I just said, by making the density disequilibrium even more severe, why would you think that?
Why would I
You've
think
taken
what?
any structural support with air pressure, haven't you? To impede
Structural support. What
the
are you
flow
talking
of the
about?
ball.
You've no idea about what you're talking about. You've no idea about gas.
That's just an ad
dynamics.
hominem
None
attack. That's
whatsoever.
called a logical fallacy, ladies and gentlemen. So when you can't address a question, just tell your opponent that they don't know what they're talking about. Make out they're stupid. It's called an ad hominem fallacy.
No, it's not. It's that's
And
when you have a
doing nothing
substitute
but
from. I'm just telling
chanting.
Yeah.
Rumpus, you're the one that took
I-
the point into a vacuum for no reason.
Yeah.
That made no point. I was
No,
just
made no point,
responding
yeah,
that
definitely.
your removal of the situation into a fantasy zone, which doesn't occur in nature, didn't help your point either. It doesn't address the point I was making.
Well, you didn't have a point.
Oh, right, another ad hom.
Because you don't listen,
Yeah,
lad.
it seems whenever we make a point that he
Maybe you
actually
don't
listens
understand them,
to,
Rumpus.
he has to tell us that it's a non sequitur. So, for example, do we have intermolecular bonds in gases and solids to make them analogous? Well, it doesn't matter. Right? Well, it does matter. It's the demolition of his argument.
If the bouncy balls were perfectly elastic,
Well,
and you put them in a
Rumpus,
vacuum, then and there was no force of friction, and they were perfectly elastic, then you would have a very good analogy for gas ones. But we all, as I think, well, Adam,
Rumpus, you just
correct thing
don't
Adam
understand,
did point out
Rumpus.
is that the balls are not perfectly elastic, so there's a limit to how close the analogy is. But it's good enough to get an idea about what's going on, because we know that when you drop a bouncy ball, it bounces up.
all the
Not quite
balls
as
ended
high
up
as
at the
it came
bottom
from,
of the
but very
container.
nearly high.
They didn't
And that's
bounce
what the gas
around.
molecule
If
do.
you
So when
added
you
heat,
claim
they
that all
wouldn't.
gas will form at the bottom, it doesn't. It bounces up just like bouncy balls bounce off the bottom on the ground, and they bounce up to a very similar height to where they came from. Go ahead.
Oh, so gas always behaves like these bouncy balls, and you're saying the bouncy balls always bounce up and out of the tank? Well, no, that's not what gas does. Gas expands. Oh, he's a coward. He's got to interrupt. That's not what gas does.
Okay.
Oh, he's going to keep
is what
interrupting.
gas
He just knows he's pummeled. That's not analogous to gas behaviour, because gas expands in all directions rapidly at high speed. It doesn't pour down and bounce like bouncy balls. They're bonded solids.
The balls, as we
Rumpus,
described,
how do you have
Please,
gas on-
Brian, please, Brian, you're not
Yeah.
helping.
Sorry.
It doesn't matter what the ball's up. We're making an analogy between the behavior of the whole ball. The whole ball doesn't matter what it's made of. We're talking about the behavior of the whole ball is analogous to the behavior of an atom. Now, it's not quite right, and Adam is correct to talk about the elasticity issue. And indeed, those balls are obviously not perfectly elastic because only atoms are perfectly elastic. And so, if you were to drop a bouncy ball into a glass container, it would bounce out again if it was perfectly elastic, and it would still do it if it was quite elastic. Depends on where you drop it from. But if you have lots of them, you can have sort of random collisions which would cause balls to eject out of the container. If they had lots of bouncy balls and they were frictionless and they were perfectly elastic, and you drop them all in and drop them, say, from 5-10 feet in a 10-foot container, eventually they would bounce around in there because they bounce up just as quickly as they bounce down. That's what bouncy balls and elastic things do. Then eventually you would get them coming out the top. Eventually, few of them would, because the random collisions would come together and cause one ball, say the odd ball, to acquire a velocity sufficiently great that it can actually go out of the container. And
I
then
see.
it would then pour energy or whatever from around it.
So,
and then that's
I
how the
understand.
atoms work.
Thank
pour
you. Can I
energy.
respond or not?
Go.
So you're saying eventually, if it was analogous to elastic collisions, then the gas would fill the space then?
But they only get to a certain height. If there was a gravitational force, which obviously there is on the Earth, it would have...
You didn't describe anything about gravity. You just described them all bouncing out of the tank, filling the space, right?
Yes, well, okay. Well,
so the gas would fill the space. That's interesting. So this description you've just given us has gas...
gravity, yes.
You're going to interrupt me? I gave you a solid 2 minutes. My God, what a coward. So you've just given us an example.
If there were no gravity...
Are you not going to let me? What a coward.
Go ahead.
So your example has gas with elastic collisions, albeit with you describing them as bouncy balls, filling the space in line with a description called the second law of thermodynamics. So eventually they'd all bounce out. He's not going to let me. So you've described gas expanding. He's never going to let me. Ladies and gentlemen, the globe's dead. Space is fake. Rumpus knows it, and he's not going to let me respond. He's a coward. He doesn't understand science. All he's got is this. This is all you got. You're not allowing me to respond. He's not letting me describe the fact that he's described what we describe now. We've taken him round in a full circle, but I've stopped him at the point that he's describing gas, analogous with bouncy balls according to him, having elastic collisions and bouncing out and filling the space.
I didn't say that, did I?
Yeah, you did. That's exactly what you described. The problem is that you forgot to introduce your fundamentalist religious zealot belief in gravity. I stopped you before you did it, and at that point you had them behaving like gas, with elastic collisions, bouncing out!
Okay, perhaps it wasn't like it was a stupid...
You stuttering bitch! How do my balls taste?
Say that was a lie.
A lie? You described elastic collisions. It didn't matter that you said it was analogous to bouncy balls at that point. You just forgot to introduce gravity, and you had them bouncing out of the tank.
So here we go. It wouldn't fill the space. So, for instance...
It wouldn't? No, that's a violation of entropy law. You don't understand second law of thermodynamics. You're stupid.
You're
stupid. Not listening. Stupid. Idiot. Not listening. That violates the second law of thermodynamics. You are a moron.
Not fill the space. They would...
No, not fill the space is a violation of natural law, dickhead.
No such thing as natural law.
Second law of thermodynamics. Entropy increase. Look it up. It's proportional to time and described quite admirably by you earlier when you described these balls in a hypothetical chamber, all bouncing out of it.
They're still subject to gravity. Nathan...
Oh, I see. So after the fact, when I pointed out that your analogy had them all bouncing out, you're now going to say that if I introduce gravity, the elastic collisions I described with them all bouncing out doesn't happen anymore, right?
Okay, there would still be the odd ball that would bounce out due to random collisions causing one ball to acquire more velocity than would be required to go out of the container. That's not the same as it filling the space. That's just the odd one creeping out and then having to return, get a little bit higher than the top of the container, and then it would fall back in due to gravity. Because there's a force acting on them, Nathan, just like there's a force bonding a brick together, and that's why that's not subject. Well, you could ask yourself, why doesn't a brick be subject to entropy and then disappear off into space?
Okay, I'll ask. Can I ask? So, does a brick have intermolecular bonds holding it together?
It does, and
does a gas have intermolecular bonds holding it together? I believe you told us on 6 separate occasions through me that gas doesn't have intermolecular bonds, but that wasn't important.
And what do you think those intermolecular...
Maybe ask me a question. So a brick, and when I ask you why it's not flying apart, it's because of intermolecular bonding.
And what do you think? Yes. And
new question and a bit of a stutter. So the brick's got intermolecular bonds. Does gas?
Nathan, those bonds apply a force between the components of the brick molecule.
And what about between the gases? Do they have intermolecular bonds?
There is a force holding the gas molecules to the Earth in the same way.
And is it an intermolecular bonding force like the brick?
Does entropy.
It's not answering, you see. So we've got a brick and we've established that that does have intermolecular bonds and that's the force holding it together. And the gas doesn't have that force, but you're going to call it gravity, after explaining that the gas with elastic collisions would fill the space.
And a brick are like the forces of gravity acting...
Oh, like the forces of gravity. So you're saying gravity's like intermolecular bonds?
Well, it applies a force to the gas molecules, just like the intermolecular bonds in a brick hold the brick together.
And there's the same intermolecular bonding force in gas, right?
No, there's not.
Oh, right, so they're not analogous then. So when we point out that PhD moron clown show Thunderfoot says that gas behaves like bonded bouncy balls with intermolecular bonds, a force holding them together, behaves the same as unbonded gases that expand in all directions to fill the space with elastic collisions. You're saying these two aren't the same, they're not analogous, right? Yeah, we know. Earlier, though, you said it wasn't important, and now your argument involves a brick with forces holding it together at the intermolecular level. Wow, it's so strange that this wasn't important 10 minutes ago, and now it's part of your argument with a brick.
In the atmosphere and the Earth, just like there are forces between the atoms in a brick.
No, gases don't have intermolecular forces between them, you stupid idiot.
There are not.
There are a stuttering bunch of bitches here. One of them's Thunderfoot Clown and one of them's you. Because no, gases do not have intermolecular bonding forces like a brick. And yet again, a flat earther's got to correct your dumbass.
Do you think there's a force?
Don't ask me something. Taste my salt.
Yes, it's the only way.
Stutter for me. That's right. Your brick has got intermolecular bonding forces you said weren't important earlier.
Same force is.
No, it's not. Gases don't have this same force, you stupid dick. Are you thick?
The same force is acting on.
No, gases don't have intermolecular bond forces, moron.
Effectively, the atmosphere
Effectively, no, they don't have them. You're stupid.
is being held onto the scales of the Earth's surface.
Oh, the scales of Earth's surface is like intermolecular bonding?
Same force is acting on the atmosphere.
Oh no, you said that the bonding's the same as the bonding between the intermolecular bonds of the brick, and gases don't have them.
They're just. Yes, but that's because I was making an analogy between the.
Oh, an analogy that's not got intermolecular bonding you said wasn't important earlier. Yes, we know.
You see, you had to interrupt me, didn't you?
What, by pointing out that the unimportant intermolecular bonds that were hand-waved earlier are now critical to your argument when you analogize between the forces the brick has, that would be intermolecular forces that were unimportant earlier, and gravity, that would fly in the face of your description of gases filling the space when bouncing with elastic collisions. But of course, that's me interrupting as opposed to summarising the absolute annihilation of your argument. Because gases don't have intermolecular bonding forces like bricks. And I'm more than happy as a flat earther to point out to you and the clown show known as Thunderfoot that gases aren't like bricks or bonded bouncy balls, because they're subject to intermolecular bonding forces. Now, gases don't have them. As much as you'd like to inject your fundamentalist religious belief in gravity and equivocate between the bonded forces that are on an intermolecular level and your zealot belief in gravity. Well, bad luck, clown show. Thunderfoot's going to have to be held to task, and you're not going to defend him as your greasy lawyering didn't help Dan. It's not going to help Thunderfoot. With that, I'll say if you are watching this on either Nathan Oakley 1980 or Nathan Oakley Premiering streams, then stay tuned as there will be an after show to follow. Unfortunately, if you are watching this live, this is where we bid you farewell. A huge, massive, enormous thank you to all of you who smashed the super chat, liked, commented, shared, subscribed, joined as a Nathan Oakley 1980 channel member, and all that good stuff. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. Another massive thank you to today's Google and Discord panel for making today's live show possible. Once again, stay tuned if you're watching on either Premiering stream. I've been Nathan Oakley, and I'll see you all in the next video.